Hello everyone, this video is part of my Docker deployment series in public cloud. In this video we will discuss how to deploy Docker containers into AWS, Google and Azure cloud using Docker for AWS, Azure and Google. This is Docker's approach to get Docker containers easily running in the public cloud. As part of this offering, Docker provides a template based on the cloud, which creates all the necessary cloud infrastructure and easily allows the containers to communicate with the cloud infrastructure items. For example, for AWS, we have the master and the worker nodes that gets automatically created. The user has a choice to specify the number of the master and the worker nodes and the type of the nodes. The security groups get automatically created. The user doesn't have to worry about what ports to open up and stuff like that. For the services that gets exposed to the outside world, the load balancer gets automatically created based on when the service gets created. So that is an additional value add. All the logs associated with these containers automatically go to the AWS CloudWatch log service. In addition to this, there is many other infrastructure internals like VPC, subnet, IAM profiles. All this gets automatically created. I have created a GitHub page for all the three cases, AWS, Google and Azure. Following is a summary of the steps. The first step for AWS will be setting up the AWS infrastructure. In this case, we have to have the appropriate permissions so that the CloudFormation template can create the necessary resources. This is needed only if you are logged in as an IAM user. If you are logged in as a root user, this step is not needed. The second step would be the creation of the cluster itself. So here is where we need to specify following or some of the major inputs we specify. The master node, the number of worker nodes and the type and stuff like that. The last step would be the deploying the application itself. In the case of Azure, the steps more or less remain the same. I'll just walk through what are the differences. The only difference in the case of Azure would be setting up the service principal. The service principal allows invoking the Azure API with whatever is the needed permissions. In my case, this is the example for the service principal creation. The other parts about creation and deploying more or less remains the same. In the case of Google Cloud, the Docker for GCE is currently available as beta. It is not available for general purpose use. If you want to try that, you need to sign up for the beta. The only thing I felt that was missing is there is no GUI based deployment option. Currently we have to use the CLI to deploy. Otherwise the functionality more or less remains the same. So now we are ready to create the cluster. So currently I am in the AWS page. So here we select the Docker Community Edition. So there is a stable channel and the edge channel. So in this case we will use the edge channel. So we click on that. So here this is going to automatically open up a CloudFormation template, and the default template which is chosen is displayed here. And once we select that template, now here we can specify what is the stack name. In this case I will choose one master node. I will choose two worker nodes. So the SSH key. So in this case I already have an SSH key, and so I'm choosing that. So this is necessary to SSH to your instances. The other options we can, we are going to use CloudWatch, we can leave that as it is. For the manager instance, I'm going to use T2 Micro, which is I think the smallest one, which is going to be the least expensive. So we can, more or less these options we can retain the same. So we can click next. So we acknowledge it and we do the create. So at this point, this is going to create the CloudFormation stack. So this will take around 5 to 10 minutes. So this will deploy the master node. This will also deploy the worker node and all the other necessary infrastructure that is necessary to create this CloudFormation template. So here when we do the view the stack, so here we can see all the options in terms of what is done. At the end of it, we can see the outputs, which would be what are the master and the worker nodes that gets created. So we'll come back after this creation is done. So we are back. The cluster got created. So here we can see that the cluster creation is complete, and if you look at the outputs, it tells us what is the default load balancer as well as the manager that got created. Now if we log into the AWS console, we can see there is one manager node and there are 2 worker nodes based on what we specified. So now if we copy the public DNS, so let's see if we can SSH to the master node. So this is the key that we used when we were creating the cluster. So this is the public IP address. So this logs us into the master node. Now if we look here, the swarm gets automatically created. So we can see 1 master node and the 2 worker nodes. And one thing I wanted to show here is if we look at the Docker PS, we see a bunch of containers that are running, and these we call them as the system containers, which basically takes care of talking between the Docker infrastructure and the cloud infrastructure, in this case which is the AWS cloud. So I've got the Docker stack voting application inside the master node. So now we can deploy the application. So now that these the services inside this voting application is going to get deployed between the 1 master node and the 2 worker nodes here. So we can see that these services are getting deployed currently, and some of the services have multiple replicas. So here if you do the stack PS, we can see the current state of the services. Let's wait for all the services to come up. So now if we do the Docker stack PS, we can see that all the services are actively running currently. So let's look at some of the integrations, how they the Docker for AWS achieves the integration with the cloud itself. So the first thing let's look at is the security groups. So if you look at on the Docker manager, these security groups, which is the swarm wide security group and the manager security group, so these gets automatically created. Now if you look at the inbound rules here, the ports that are necessary for swarm is automatically present here. And the next thing we'll look is the load balancer part. So now if we look on the load balancer side, so we should be able to see the elastic load balancer that gets automatically created. Not just the fact that the load balancer gets created, the port forwarding is automatically determined based on the services that are created in our cluster. So the services that we deployed, the voting application exposes these 3 ports, 5000, 5001 and 8080, and the load balancer gets automatically created and forwards these external ports to the routing mesh that is created within the cluster. So this is the second integration. Third one we look is the CloudWatch integration. So for that, let's get into the CloudWatch. So here we should be able to see the stack that we deployed and the logs associated with all the services that we are running. So if we click on the logs, so here we can check what is the log associated with each service. So we can see all the details here. Now we can try to access the application. The application itself can be accessed through the load balancer. So here we are in the load balancer place, and we can get the DNS name associated with the load balancer, and we can try the 3 ports that is being exposed. One is the visualizer, which shows one manager node and the two worker nodes, and then we can check the voting app, and we can see the two containers here. And we try to refresh. Load balancer would automatically take care of load balancing between the two containers. So once we are done with this particular stack, we have a choice either to update or delete the stack. The update stack is going to see if there's any necessary reasons to upgrade either the Docker version or the stack itself. And the delete stack would clean up all the resources associated with the cluster, so we don't need to delete every individual resource here. Docker for AWS and Docker for the GCE is more or less similar. So I have put GitHub pages, wherever there are smaller differences, I've captured them in the corresponding GitHub page, but more or less the procedures remains the same. Thanks for watching.